Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we are going to build an optical character recognizer that can recognize our handwritten text. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding the problem statement and the workflow that goes along with it. Moving ahead, I'll be talking about the tools and frameworks that we'll be working with and finally walk you through a hands-on demo in order to implement this project. Guys, before we start, please do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're someone who's looking forward for deep learning certification using TensorFlow, please check out the link given in the description box below. So coming back to our project, here the main agenda of this particular application or the demo that we are going to show here is that we'll be using Python's GUI library, let's say Python GUI library like pygimps. And what we're going to do is we're going to just trace a character. Just for the sake of simplicity, what we'll do is we'll trace a character of digits. So if I write 8, what it should do is it should create a bounding box. And within the bounding box, we'll have that represent what character it is, like whether it's 8, 7 or 9. So with this, what we're going to learn is there are two things. First off, we are going to see how we can train our MNIST data or how we can train a model. And then whatever the training model we have, right, like .h5 file, we're going to see how we can implement that in a real-time scenario. I'll be using Pygame module, and Pygame, as we all know, is one of the popular Python library, which is usually used for developing games. So why am I using Pygames over here? The reason is because Pygames give me access to that infinitely running loop, and I can modify the loop in such a manner that, every time I press a key, the whiteboard or the blackboard gets erased, whatever is there. And apart from that, it's pretty easier for us to implement this. So let's now see what would be the workflow here. So as I mentioned earlier, first off, what I'm going to do is I'm going to create a model. We would be using Jupyter Notebook to get the dataset, and the dataset I'm going to use is Keras built-in dataset. And then we are going to train a model. In order to save time, we'll be making use of either the pre-trained model, and as the dataset is pretty small, I would be going with linear architecture, or else we can just develop our very own model. And apart from that, once we're done with developing a model, we're going to save that as a .h5 extension. We'll see how we can create a function which every time I pass a data or every time I create a drawing on my blackboard using Pygame window, just for that specific board or just for that specific trace, how we can, implement optical character recognition. So let me now quickly walk you through what are the frameworks and tools that I'm going to use. As I'm already discussed about this, in order to train my model, the platform that I'm going to use is Jupyter Notebook. Here, I'll be making use of a Jupyter Notebook, which is provided for me by the VS Code editor. And apart from that, the framework that I'm going to use for developing my model would be TensorFlow. And apart from that, I would be using supporting models like NumPy, Pandas, and Matplotlib. And coming back, developing our application, that is the Blackboard. In order to develop my application, I would be making use of my Pygame library. And here you will see that, what are the various aspects I can use to modify my input credentials. So now without any further ado, let me now quickly jump to my code editor and show you how we can develop our model. So now that we are over here, what we'll do is let's import some of the libraries. So first off, I'm going to import NumPy as NP. And apart from this, we'll also need, let's say, import matplotlib.pyplot as PLT. And yeah, this should be it. And apart from that, I'll also import Keras. And now if I need a data set, as we all know, there are three ways. Either I can scrap a website or I can refer to any website like Kaggle or something where I can download my data set explicitly. Or the other way is I can just go to Keras. So from Keras.preprocessing, or no, it's going to be dataset, import, we just need the MNIST. So it's going to be MNIST. And this is all there is. And let me now execute this. So meanwhile, that's getting executed. What I'm going to do here is give a comment here. Let's say this one over here. Let's say get the data and pre-process it. So now that we are over here, what we'll do here is we have this MNIST. So MNIST has this function. And what this MNIST function does is load data. And if you want to see what this thing loads or what this function does, just write this question mark and try to load this. So we'll get some documentation about this. This says there are a data set of 60,000 images, that is 28x28 grayscale images. So there are 10 number of digits, that is 0 to 9. And then we can see there are 10,000 images for the test data set. And finally, this is what this thing returns. So we'll copy this. And so let's now come back here. And let me pass this. And this would be equal to that. So let me now execute this over here. Fine. This looks like we have executed this. And now what we'll do is every time you're trying to write a code, make sure you write it with respect to the industry standard. So now if I have to tell you over here, let me zoom in a bit. So as you can see, we have this X So this X is usually in a uppercase and Y is in a lowercase. And this is what we follow in the industry. This is industry standards. And now what we'll do is let's see the shapes. So we have xtrain dot shape, and then we have ytrain dot shape. Similarly, we'll write here as xtest dot shape and ytrain dot shape. It's going to be ytest dot shape. And let's execute this. So as you can see here, the size, we have 60,000 images, 28,28, and this 60,000 is because it's the output. And similarly, we have 10,000 images, 28,28 dimensions, and this is gonna be the output variable. Like, it's basically telling me, what is present there. So now what we'll do is we'll try plotting this image. So let me zoom out just so that you can see it clearly. So let me quickly give you a walkthrough. First off, we imported our dataset, imported our libraries, then we got our dataset, and now we'll try to see or visualize our data. So in order to see this, we just can't plot it. Like if I just say plt.imshow, and if I just put here xtrain of 0, like image present in 0. So if I try to run this, as you can see, we are getting this. And now what I'm going to do here is cmap binary, and let's execute this. So as you can see here, we are getting a binary image. So what we'll do, we'll write a function. So let's say something like plt.show, and we'll also give a title here, plt.title, and the title over here would be ytrain of whichever the index, and here as well I'll give the index as I. And now we are going to write a function def plot input image, and here we are just going to pass the image over here. And let me quickly get this sorted out. Looks great. So now let's say we want to print out first 10,000 or something like that. So all I need to do is pass the index values for I in range. So let's say first 10 values, and now we'll just say plot input image, and we'll just give index over here, and let's run this up. So as you can see here, let me scroll up a bit, let me zoom out as well. So as you can see, first off, I need just 10 images. These are the labels over here. This is present in Y, and this is the actual image. And if you want me to remove the axis, so it will be plt.axis, and we'll just put here off. So as you can see here, we have all the images, we have the labels. If it says 1, then we have 1 here, we have 9. All of these are handwritten images, and these are just the top 10. So now that we have loaded our data and we have also seen our data, what we are going to do now is to pre-process the data. So let me give a comment here, pre-process the images. So what we're going to do here is first off xtrain. This would be xtrain.asType. We'll give this as float. We'll just give np.float32. And now we'll divide this by 255 because I'm trying to normalize this. Similarly for xtest, I'm going to perform the same task. So let me copy this and paste here. Instead of xtrain, it's going to be xtest. So this is going to be xtest. This looks great. So let me give a comment here as well. Let's say normalizing the image, one range. And now what we'll do here in the next stage is we have to expand the dimension, because when I try to pass this through my machine learning algorithm, so or any model, I'll tell you what I mean over here. So xtrain, and if I put here dot shape, so as you can see, first off we have 60,000, which is the batch size. Then I have 28 and 28, but I also need to add 1. This is because it takes in the 3 dimensions. So what we'll do is xtrain is equal to xtrain dot reshape, or I can just use np dot expand dimension, and here I just need to have which value I need, xtrain, and I want that to be present at -1. So index is going to be -1. Similarly, I'm going to do it for xtest. So instead of train, this is going to be test. So let me quickly give a comment here for you guys to understand. So here this is going to be reshape or expand the dimension of images to 28. That's because 28 is the size of our MNIST data, 28, 1. And now if I try to execute this, and now if I try to just run this here again, so now you can see it's 60,000, 28, 28. Let me rerun this. You will see we have 1. So this is pretty important. So that is all about pre-processing our image. Now what we have to do is, now we have to convert our output variables, that is Y. Let me quickly close this for you guys. So we have this output variable Y. So if I put Y now, it's going to be the 1 0 1 0, or the value of Y would range from 0 to 9. So I'm going to convert that into one hot vector. So what we'll do here, we have this built-in function, that is from. So the built-in function, either we can import it, or we have like keras.utils. Then we have to put numpy utils. This is pretty important. So that happens only when the case of NumPy. But if you are using Keras utils, then you can just do two categorical. And then here I'll just pass my values. So it's gonna be Y. So as you can see here, Y. So I'm gonna pass Y test and Y train. So Y train, and let me add this here, Y train, and let me execute this. So if I try to run this now, Y train, this is gonna be one hot vector. So wherever the value is present, like wherever the value is there, only at that place or only at that index will have 1. Rest everything is gonna be 0. Similarly, we'll do this for Y train or Y test. We'll add Y test here and Y test over here. So now that we have pre-processed even our output variables, let me add this to just one block, just to keep the code clean. And let me zoom out a bit and let me write a comment here, convert classes to one hot vectors. So now that we are done with our model, what we are going to do is let's quickly try to build a model and let's see how well that works. So to build a model, I have to import a couple of libraries. Let me scroll up now and let's see what we have to import. From keras.models import, we'll import sequential model. We don't need functional API, so we'll import sequential. Apart from that, we also need layers. From keras.layers import, let's say we need dense layer. So we have done a mistake here. It's going to be from keras.layers import dense layer. Then we need con2d, and apart from that, we also need something like maxpool 2d over here. And then we also need to have flatten, and then finally dropout. I'm going to use dropout just to prevent overfitting. And let me execute this once again. Come down here and we'll start building our model. So first off, model, we'll initialize this to sequential. And now what we'll do here is we'll just have to add the different layers. So it will be model.add. And for this, what I'm going to do is first off add the input layer, or I can just directly start from con2d. So con2d, let's see if we have imported the correct one. Com2d, let me scroll up. Yes, we have imported the correct one. And now what we'll do is we'll just pass a couple of values. First off, I'll keep 32 here in the initial stage, number of units. Then we have kernel size. Kernel size, let's say I'll give 3x3. 3x3 is an industry standard that we use. And apart from that, we have to provide input shape. So the input shape, as we all know, it's going to be 28, 28, 1. And finally, we have to give activation. And the activation I'm going to use here is relu. So this is the first convolution layer that we have added. Next, we are going to add maxpool. So model.add, and this will be maxpool. And here we are supposed to pass the pool size, and the pool size would remain the same, that is 2x2. So now what we are going to do, we are going to add 2 more convolution layers. So instead of typing it again, I'll just copy this from here, paste it here. I'll remove the input shape. Let me tell you, you have to provide input shape only once. Let me remove this. The only thing that I'm going to change here is increase the size here, or number of units. So it's 64. And as this is a small data set, we won't complicate this stuff. Now all we'll do is model.flatten. Let's say flatten layer. And then just to prevent overfitting, we'll just give model.dropout. Let's drop out to 50%. First off, it's going to be add, and then we'll have to add dropout here. And it takes like 0.5, that is 50% of it. You can also make it as 2.5. So it's totally up to you. And then finally, we need the dense layer. So it will be model.add. So dense layer is basically used for classification. So dense. And now we know that number of classes here is going to be 10. That is from 0 to 9. And the activation that I'm going to use here will be softmax. So this is all there is about building a model. First off, we initialize it with sequential. Then I add a 32 filter convolution layer, and 2x2 maxpool layer. Then again 64 unit convolution layer, again maxpool, and then flatten. We'll drop it out by 25%, or we can also keep it as 50%. And at the classification layer, I have 10 neurons. That's because we have 10 number of classes. Let me execute this, and let's see model.summary. So as you can see here, first off, we have 26, and then that decreases over here to 13, 11, 5, and finally the classification we have 10. So this is it about building a model. Now we'll try to compile it. Model.compile. So first off, optimizer. So this would be Adam, and then we have loss. So this will be, let's say, keras.loss, and here we are going to have categorical cross entropy, and finally we have metrics, and this would be accuracy here. So let me execute this. And now what we'll do, we will try to train a model, but before that we'll also have callbacks. So for callbacks, we have, let's say, callbacks. Let me give a comment here. So the callbacks that I'm going to use is early stopping and model checkpoint. So from keras.callbacks, import early stopping and model checkpoint. We'll first off define early stopping. Okay, we'll give it as ES, early stopping. This would be equal to early stopping, and this has a couple of variables. First off, it has to monitor what parameter. So I want this to monitor validation loss. I want it to monitor validation accuracy. Then minimum change in delta. Let me give this as 0.01. And the patience, let's say we'll give it as 4 trials, and verbose will be 1. So this is early stopping, and then we have model checkpoint. That's MC, and we'll call here model checkpoint. Even this thing takes a couple of parameters. First off is file path. So I just want it to be in the same directory, and let's say best model. And don't forget the extension .h5. Then even this, I want this thing to monitor validation accuracy. Verbose would be 1. And finally, save best model, I want this thing to be true. So let's see what are the other parameters that are there. This looks great. Now what I'm going to do is I'll create this callback CB and I'll add them into an array. There'll be early stopping and model checkpoint, and let's execute this. So now that we are finally done, we are going to train our model. So we have this history, HIS, and now we have this model. So model.fit, and what this takes in is X train, then we have Y train, and then finally we also have to mention number of epochs. Let's give it as 50 because anyways I have early stopping here in place, so we don't have to worry about model being overfitting or not. And apart from that, we can also give it as validation split, that is this one. So we have validation split. As this is a very huge data set, let me give it as 0.3%, that is 30% over here, and I think this should be it. So shuffle is equal to true, sample weights, and let's see if we are missing out on anything. So we are done over here. Let me execute this and let's see how long it takes to train a model. So as you can see here, we have successfully trained our model, and our model accuracy over here is 98%. And now if you want to evaluate this against our test data set, let me close this off. So this is what I used to train, and make sure you add the callbacks. And I have also saved the model here. Now in order to use this model, let's say model underscore save. So let's give S. We have this function called as keras.load model. And now all you need to give is the path over here. So let me copy the path and pass it over here. And make sure if you're someone who's working with Microsoft, you have to do these changes, and this is done. So now we have loaded our model. What I'm going to do here is model.evaluate. So I'll give here a variable score, and let me zoom in a bit just so that you can see it better. So what this model can do is model the saved model dot evaluate, and all I need to pass over here is the xtest value and then ytest. And what this would return me, let's say print, I'll have string here. The model accuracy is score of 1. 0 returns me the loss, and the first the element in the index 1 returns me the score present in the accuracy. So let's wait for a moment. Let's see what happens. So as you can see here, our model accuracy is 98%, and the loss over here is 0.3, which is negligible. So this is my model, and I have successfully trained my MNIST dataset. So now what's going to happen is, if I have any image, like the image of a handwritten, whose size is like, let's say 28,28, I can easily pass this through my model, and my model will easily predict whether that belongs to which class. So now what we're going to do is, we are going to come back to our app.py, and now we are going to write a function, or let's say now we are going to write a code in such a manner that we are going to use first off Pygame modules, and let's see what happens over here. So first off, what we'll do here is we'll import some libraries. Let's say import Pygame, and let's also import something called as system. And then I also have from pygame.locals import star, that is import everything. Then we'll also import some generic one, import numpy as np. Let me just close this off for now and save this everything here. And let me minimize this. As now what we'll do is from keras.models import load model. We all know why we need load model. So we have this .h5 file. Just to use that, I'm going to use load models. And then I have import CV2. This is just so that I can read the image. So it's going to be CV2. So now what we are going to do, first off, if you're working with PyGames, we have to create our application window. So in order to create an application window, we have to give the size of it. And before that, we have to initialize our Pygame module, pygame.init. So let me give comments here so that it's easier to understand. Initialize our Pygame. So now what we'll do is we'll have pygame.display.setMode. And here we are supposed to pass the window or sizes. So let me just give a tuple here. And now let's say window size X and window size Y. So I'll have here window size X, window size X, and window size Y. And we'll define this over here as an external variable. So let me come down here. So the size of the X dimension, this is going to be 640 pixels, and this thing over here is going to be 480 pixels. You can try out or do experiment with the number that you like. And now what we'll do is let's try to run this and let's see what happens. So as you can see here, we are not finding any errors. So that means everything is running fine. And apart from that, as you just saw, we are getting Pygame window. So this means that we have installed Pygame properly and everything is running fine. So the only issue that we have now is to retain our display. So in order to do that, we'll be using while loop. So we'll say here, if I close this, you can see we get this Pygame window. And now what I'm going to do is while true. This means that this is an infinite running loop. So first off, what I'm going to do is create an event loop inside this. So event loop is basically responsible for capturing any of the event that is happening here. So there will be for event in pygame.event.get. That is capture any event which is, let it be either from mouse or keyboard. It doesn't matter. So if event.type is equal to quit. If this happens, then I want to close my window. So pygame.quit, and then we'll also do system.exist. So this looks great. And let me quickly run this up. Let me save this and run this up. So as you can see here, now we have this Pygame window. And if I try to close this, this automatically closes up and doesn't give me any error. This is a bit about Pygame. So first off, I have initialized this. I have given the window size, and then we also have while loop. So now what we want is every time I run this, so let me show you what happens. So every time I run this, what I want over here to happen is, let me take a pen. If I type 8 like this, what I want is I want a bounding box this way. And this bounding box would be sent to my model. And my model will predict what character it is, and it gives us a label over here. It's a label 8. And now if I press an escape button, I want all of this thing to get vanished. So this is what we are trying to do over here. So let me quickly erase this and close this window as well. So before that, let's give some attributes to this. So let's say font. This would be Pygame. This is basically giving a font or a text to our window. So font. And now we can just give any font over here. So let's say free san bold.tff. And then I'm going to pass here 18. And we also need to give a caption to our board. So for that, it will be pygame.display.setCaption. And let's give it as blackboard, or let's say digit board. And this is optional. If you want, you can just add it up. Totally up to you. But let me comment this for now. And one more thing that I would do here is have a background. So for that, let's have a variable file in it. So this will be display surface dot map underscore RGB. And here we just have to pass white. What I'm going to do now before this, so I'll come back to this later. So first off, let's have the colors over here, white. We all know white stands for 25 or 255, 255, 255. And we also have black. So black over here is 0, 0, 0. And then I also need red. So in red channel, I would just make it as 255 and rest everything would be 0, 0. And now we also have done like window size. Window size is done. And then if you want to save an image, we'll also have a variable for that, image save. So let's say initially we don't want to save our image, so it will be false. And let's say I want to load my model. So model is equal to, we have this Keras library, so it will be load model. And all you need to do is pass this path. Let me copy the path, or let me take the relative path, add it over here. And we'll also set a mode, let's say predict. We'll come to that later. Apart from that, we also have labels. And this label is basically a dictionary. So what this thing refers is if it's 0, right? If it predicts 0, then I want it to be 0 in text. Similarly for 1, and then we have 2, 3, and we'll do it for all. So as you can see here, we have successfully added all our labels. So my model would give me whether it's 0, 1, 2, 3, and I just want to convert that into a textual form. That's why I'm having these labels. So let me run this again. Let's see if we have any syntactical errors so far. So we are having this Pygame window. That means we are not having any syntactical errors so far. Let me rerun this again. So as you can see, we have given the label here as well, digit board. So this is all there is about labels and models and everything that is done. So now we have two tasks. First off, we have to draw our image on our board over here on the Pygame board. And the second task is whatever I draw, I want that thing to be captured and sent to the model. So all of this is whatever task I said now, everything is going to happen in this infinite learning loop, or I would like to say it as system loop. So here we'll write if condition here. So within the event loop, if event dot type is equal to mouse down or mouse motion. So this will be mouse motion and is writing. If this is the scenario, we have to do something. So before that, let's define our variable is writing. Let me have this here to false. So now what's going to happen is I need x coordinates. So x coord, and then I also need y coordinates. So this will be equal to event dot position of the mouse or the place where we have written. And then we have pygame dot draw, and all we need to do is dot circle. So we have to provide a display surface here. I don't think we have defined a display surface. So yeah, we are going to define a display surface. So meanwhile, let me just write here display surface. We need a white background, so it will be white, or the text that we write has to be in white. And then we'll pass coordinates. So it's going to be x coord and y coord. And finally thickness, that's going to be 4, and this is brightness. Now first off, we have to create this display surface. So let me give it a surface, and let's define this display surface here. So now that we are done, one more thing is this is writing is false. So is writing is false. We have to make that true. So for that, what I'm going to do, so if event dot type is equal to mouse button down. So whenever the mouse button down, is writing would become true. Here we are getting the positions of our coordinates. So we are going to append these values here. So for this, let's say number x coord, which is basically an array. And then again, I'll give this as a lowercase number y coordinate. And here again, this would be an array. So what we'll do, we will append these two values over here. So let me copy this and paste it over here. And now instead of bracket, we just have to use append over here. And similarly, y coordinate. So this looks great. We have a display surface over here. Let me save this. We have a display surface. Display surface is present here. So let me change the name. Display surface we have whiteboard, which is this part 255. And then we have the coordinates and 4, 5. So basically you're trying to draw a rectangle or a circle that you can say. This is what happens when the mouse is in motion and we are trying to write this. Now what I want is when I'm done writing, I have to capture that whatever I have done. So for that we have mouse button up. So what we'll do here, if event dot type is equal to mouse button up, that is once we are done with our writing, then is writing goes back to false. And now we have number, that is x coordinates. Let's take that up and we'll sort this up. And similarly we'll do it for the y, number y coordinate, and we'll have sorted y coordinate. This is going to be number y coordinate. So this is done. Now we have to create a rectangle. Let me show you what I mean here. Let's say I created this 5 and this is my box. So what I want is I would definitely get this coordinates. Now I also want to create a rectangle over here. So this is what I'm trying to do over here. I got the coordinates. Now let's try to get the rectangle. So let's say rectangle minimum x and then max x. That is one for the right side and one for the left side. So rect. So this is going to be max and this is going to be for the x side. So max. So this will be number of x streaks present in 0 index minus boundary. Boundary is a parameter, that is something which we have to define here. So let's quickly do that. So boundary int, let's say boundary, let's come up here and let's define boundary. And we'll give here as 5 pixels. We can give any value you want, 5 pixels. Similarly, let me just copy here boundary int and then we'll pass here 0. So this is for the left hand side. Now let's do it for the right hand side. So we'll take minimum value. So it's going to be lowercase. Window size X. Then we have number. We need the X coordinate. We'll take the -1, that is the last value, plus boundary. Okay. So boundary basically you can just say it as a padding layer. So this is for the left hand, right hand side for the X coordinates. Now let's similarly do it for the Y, and we have done a small typo. This is going to be underscore. Similarly, we'll do it for the Y. So let me just copy this, zoom out a bit, and let's similarly do it for Y. Everything remains the same. We just have to change certain values. So instead of X, it's going to be Y here, and even this will remain the same, Y. Now instead of X coordinate, it's going to be Y coordinate. And similarly here, instead of X coordinate, it's going to be Y plus the boundary. So let me reduce this to a lowercase. So this is all there is about getting the rectangles. Let me make this as lowercase. And once we are done for one particular digit, so we have to obviously like reinitialize it. So we'll do it as num X chord. It will be an empty list again, and number Y chord, this again would be an empty list. So image array. So what's going to happen here is np.array. We are supposed to extract that. Now we are supposed to just extract just the part which is there in the rectangle boundary. So what I'm going to do here is numpy array. So we have this pygame.pixel array. That is, I just need the pixel values which is present in the display surface. So let's give display surface here. And now we just have to give a rectangle, now we just have to give coordinates. So we have a rectangle minimum X, okay, max X. Similarly, we'll give to rectangular. So this is going to be from left hand side to right hand side. So this is going to be min, right? Minimum to max. This is one thing. And the other one is from top to bottom. So it's going to be a rectangle minimum Y to maximum Y, max Y. So now that we are done, we'll just take a transpose of this. So dot t, and then we also need this to be in the form of float. So as type float. So now what we'll do, we'll just try to save this image. If image save, that is if I want to save the image, then we just have this cv2.imwrite, and you just have to pass a value, let's say image.png. This is just the file name. And then finally you have to just add image. So image count plus equal to 1. The reason why I'm doing this is because just to have a batch size. So over here we're supposed to define our image count. So let's say that image count is equal to 1. So this is the case if you want to save it. Usually you would keep it off. Now comes the point where we are trying to incorporate Python with machine learning. So this is the place where we are literally trying to predict what we have seen. So if predict, so predict is basically a variable, and let's define this somewhere over here. And let's say this is to be true. So first off, what I'm going to do is image, and I'm going to resize it. So it will be cv2.resize. We are going to pass image array here, and then we are going to pass a shape that is 28,28. The reason why I'm passing 28,28 is because my model has been trained on 28,28. Then I have image. Then we have np.pad. I'll pad that for my image, and I'm going to add 10 pixels. Okay, so image add 10 pixels, 10,10. This is just so that I don't lose out on any information. Then I'll also add constant. So the constant value that I want over here to be 0. So let me put here constant values. This is 0. So this is done. Now we'll try to normalize our image, but before that let's resize it. So image is equal to cv2.resize. We want to resize our image, and then I will just add here 28,28, and then we'll try to normalize this. So this will be white int. So basically this is referred to 255, right? So this is going to be the white int value over here. So the value of this white int is going to be 255. So I'll just divide this by 255. So now what we'll do, now we'll just directly go on to a prediction. Let's say label. So we'll have str of labels. Basically what I'm trying to do over here is list comprehension. Now let's say np.argmax. This is what this thing would return me. np.argmax. When I try to perform any predictions, so I'll be getting the list of the probability distribution, and whichever index has the highest probability distribution, that means it belongs to that particular category there. And now we have our model. So this is where we're going to do model.predict. So this is going to be model.predict. And now we'll just go image dot reshape whatever image that I'm going to pass. I obviously have to reshape it to 1 comma 28 comma 28 comma 1, and all this is going to do is just give me the label, and this is what we're going to add over here. This label is going to get itself compared to this value over here. So now what we'll do, we'll go, let's create one more variable here. Let's say text surface over here. Let's say font dot render. We'll add here label. Then this has another value that's called true, red and white. These are the colors that we have defined earlier over here, red and white. Now we'll add the text to our rectangular box. So text surface, or let's say text rectangular object. This will be text surface dot get rectangle. And again we have text rectangular object dot left. Now we are just trying to provide the coordinates left and then for bottom. And now we'll pass here rectangular minimum, that is minimum x, and then rectangular minimum y, that is basically top left corner. So this is done, and now we just have to update this. So display surface dot blit. So blit I usually use to display my object, and now I'm just going to pass here text surface object. So this is going to be this part here, text surface, and then text rectangular object. So let me do that as well, rectangle object. So this is all there is over here. So now what we'll do is we'll have one more event loop, that is if event dot type is equal to key down. Then we have if event dot type, let's say if I'm trying to add some unique code value, that is n, then what I want to do is display surface dot fill black, that is basically reset my display surface. Display surface dot fill, and this would be the color black. So this is all there is. And before that, what we'll do is we'll try to do pygame dot update, which has to be within this while loop. So pygame dot update. So this is all there is over here. So finally, let us quickly run this and let's see what happens. So now that I've started running this, we should get a pop-up of our pygame window. Let's wait for a second or two. So as you can see here, we have this pop-up window. Now if I try to write 8 over here, now you can see our model is detecting it's 8. Let's say we take off 1. The reason why this is detecting 2, because it looks like 2, right? So it looks like 2 over here. But let's say if I add 1, so this is 1. And now if I press N, you will see everything is replaced by this black sheet. Now if I add 7 here, this is 7, 6, 5. The moment I lift the key of the mouse cursor, the prediction starts. So this is going to be 4. And let's say 9 over here. And 0 if I give it properly over here. So as you can see, it gives me 0. But similar to this, if I say 0 and if I add another line here, now it should give me 9. But it's supposed to give me 8. So 8 means it will be oval this way. This is a simple project that you can do where we are trying to make use of an optical character recognition, where we are using deep learning to build a model. Whatever we are trying to achieve over here, whatever is present over here in this rectangular box will be passed to a model, and we're going to create the predictions over here. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!